Hey guys, this is Ms. Nisha, and I'm here to go over your Mod 3 math with you. So we're going to get into it. Okay, so first you have insulins. You will be responsible for being able to identify what type of insulin it is and how it works. So for example, you'll have about 4 questions on this, one for each. So Humalog is rapid acting. You would need to know that. In the red below each label, I provided just a little mnemonic or a little trick to help try to make this information stick. If it works for you, great. Okay, but you have rapid acting, intermediate, long acting, and regular. Okay, so you need to know those when you see the name of that insulin. You will also have insulin syringes. So you're going to need to know how to identify the syringe that you're using. So I gave you 2 examples here, but there is a third. You have the 30-unit syringe, you have a 50-unit syringe, you have a 100-unit syringe. Make sure that you know what each one of those lines means on that syringe. So for example, each one of these, each line is just 1. But on a 100-unit syringe, those lines could be 2. So you'd count by 2s for each one. For example, if you didn't know how to tell, let's say we start here at 5, and then I count each line from 5 to 10. So 5, 6, 7, 8, 9, 10. I end up at 10, which means each line is 1. Okay. If you try that and the next larger number that you get to doesn't make sense, then try by 2s. Okay. And see if you get your answer then. So make sure you know how to read these. And then let's say that you have an order and it is to give your patient 21 units. You need to know how to identify that, right? So here's 20. 21 would be the very next line after. I'm going to try to get my pen on there. Right. Okay, so 20. One more would be 21. So that would be our 21 units. Okay, so make sure you know how to read that and how to find that. All right, the next thing you will need to know is insulin sliding scales. How do we read an insulin sliding scale? So here you have your patient's blood sugar before lunch was 149 milligrams per deciliter. You're going to look at this sliding scale, and on the left side, it shows you what their blood glucose level ranges are. So you're going to find, based on what you obtained, where does your patient fall on this sliding scale? Okay, so the first one says 60 to 120 milligrams per deciliter. If my patient fell in that range, they would get no additional units of insulin. If it were 121 to 140, they would get 2 units. But ours was 149, which puts us right here. Okay, so 141 to 160, which means our patient would be getting 5 units. Okay, so make sure you know how to read this and figure out how many additional units your patient may be getting per their sliding scale. Okay, the next thing on there is reconstitution. So in this example, how many mLs of diluent are recommended? So your diluent could be sterile water, saline, lidocaine. It's basically the fluid that you're adding into this vial. Remember when we reconstitute, in the vial is powder. So the diluent is how much of a solution or fluid that you are adding in to now make this liquid and usable. Okay, so for the diluent, I highlighted it on here already for you. You're looking for something that along the lines of reconstitute with, okay, or dilute with. Either of those keywords will let you know that that's what they're telling you to add into your vial. So this one says reconstitute with 1 ml of 1% lidocaine hydrochloride or sterile water. Okay, so the answer would be 1 ml because that's how many milliliters it's suggested to reconstitute with. Okay, so there's that. Make sure you understand this one. The next one, if you have a question that's asking you after reconstitution, how much do you have? They're asking you, once you add that liquid into that powder, we mix it, and we're ready to use it, how much is available now in this entire bottle or in this vial? Okay, so you're going to be looking for keywords like after reconstitution or when mixed. So right here on the label, it says 55 mLs after reconstitution. Okay, so that's what you're going to be looking for if we want to know how much is available once we add our liquid in. The next thing, and there are quite a few questions on this, so this one's going to be a little fun. Okay, so this is for your intake and output, or your INO. On this slide, I provided a little cheat sheet here. It just reminds you of what to count, what not to count. Okay, so for INOs, we are counting liquids. Okay, and not only are we counting liquids, but we're also counting things that can be liquid at room temperature. So think about if it melts, you're more than likely going to count it. Okay, so that means Jello, ice cream, those types of things get counted as well in an INO because at room temp, they are liquid. Okay, do not count in an INO or an intake and output. Don't count your solids. So don't count their sandwich, their eggs. Cereal usually won't get counted because of the cereal that's in it. Okay, even though there's milk there, the cereal excludes it. Eggs, fruits, vegetables, pasta, none of those get counted. Okay. And then here at the bottom, there is also included how to calculate. So you want to remember when you're calculating INOs, 1 ounce equals 30 mLs, which means if we have to convert anything, 30 is the number you're going to use because 1 ounce equals 30 milliliters. Okay. For the next set of questions, you also need to know output. So we would count for output anything like urine, emesis, which is their vomit, if they have any type of drainage tube, or liquid stools. So diarrhea, if we can capture it and measure it, we're counting it. Okay. Also, when we talk about intake, not only do we count the liquids that they eat or drink, but we also count their IV. That is also a fluid that has to be considered in an intake and an output. Okay. So this cheat sheet is here for you. Make sure you go over it. Make sure you study it. And we're going to get into the questions. So you will start off with a question about breakfast. Okay. And this is a sample intake for breakfast. So for breakfast, your patient had coffee. Okay, so their 1 cup of coffee is 8 ounces. They had 4 ounces of orange juice. They had oatmeal. They had eggs. And they also had 8 ounces of milk. Remember, we don't count their solids. So oatmeal, we don't care about that one, nor the eggs. We care about the liquids that are listed. So I'm going to show you 2 ways that you can calculate this. You pick which way is easier for you. Okay, so one way that you could do this is, for coffee, we have 8 ounces. So here is our 8 ounces. And I know that to go from ounces to mLs, I multiply by 30 because 1 ounce equals 30 mLs. So when I do this, I get 240 mLs. Okay. I could do that for each one, and I'm just going to write it out on this one for us. So the next one was the orange juice, which was 4 ounces times 30 equals 120 mLs. And then the next thing my patient had was milk, which was 8 ounces times 30, and we have 240 mLs. Okay, once I have that, I can add that all up, all right? And I should have got 600 mLs, right? So that's one way you can calculate it. The other way that you can calculate it is just 8 ounces plus 4 ounces plus 8 ounces, okay? And once you do that, I'm going to pull up my calculator and calculate with you. All right, so the 8 plus the 4 plus the 8 gives us 20 ounces. Okay, and then I still have to multiply that by 30 because that's what I need to convert it. And I should still get 600, okay? And that's mLs because we want to know how many total mLs that they consume. Okay, so whichever one works for you, whichever one is easier. So you can calculate each one and then add it up, or you can add up your ounces, multiply them all by 30, and get the same answer, okay? Moving forward, make sure that you keep this number written somewhere, okay? Put a box around it or something so you don't forget. Label it if you need to, but for breakfast, we had 600 mLs, so don't forget that, okay? Then we're gonna move on to lunch. So for lunch, we have a can of soda, which was 12 ounces. We have our soup, which I'm actually going to change in just a moment for you. And we also have gelatin. Remember, gelatin or Jello, when at room temp, is a liquid, so we're gonna count it. I am going to change our soup though, so we're going to say they had 3/4 bowl of soup. 1 full bowl is 8 ounces, okay? So this is for 1 full bowl. All right, so 1 full bowl is 8 ounces, but your patient did not eat a full bowl. They ate 3/4 of their soup. So I'm going to show you how to calculate that with the fraction in there, okay? So let's start with that one actually, and then we'll add it all together. So if they had 3/4 bowl of soup, you can do the math with a fraction. Most people don't like the fractions, so let me show you how to get rid of the fraction. So 3/4, okay? If you plug that into your calculator, 3 divided by 4, you're going to get 0.75, okay? 0.75, usually working with the decimal is easier, so you can do that. So 0.75, that's ounces, okay, because they didn't have the full bowl. All right, and then I have that. I need to figure out how much of that is from that 8-ounce bowl, okay? So to figure that out, we're going to multiply it by 8 because that's the total amount in the bowl. But I'm trying to figure out, well, how much did they actually consume if they didn't use the whole bowl? So 0.75 times 8, okay, and we get 6. So they got 6 ounces, okay? But am I done? And the answer is no, because I'm still in ounces. So all I figured out right now is my patient had 6 ounces of soup, okay, because they didn't finish their entire bowl. So now that 6 ounces times 30 will now convert me into milliliters, and then I'm almost done. Okay, so this will give me 180 mLs. Okay, so now you figured out the soup. From there, you can do the rest. So on this side, we are doing 12 ounces, because now I'm looking at the soda, times 30. Okay, so you're going to do 12 times 30, which is 360. Okay, and then the last thing here was the 4 ounces times 30, and that is again 120 ounces. Now I'm going to add that all up. So I have my 360 plus 120 plus 180, and that gives me 660 mLs. Okay, so that's for lunch. Again, if you want to do it the shorter way and just add up all of your ounces, then you're going to do 6 ounces, because remember, this is how much they really ate of the soup. So 6 ounces plus your 12 ounces plus your 4 ounces. Okay, and that'll give you 22. So 22 ounces times 30 equals 660. So we're still getting the same answer. So either method works. Okay, just remember what you get from that. So now we know lunch, and lunch was 660. Okay, now for dinner. So dinner, I'm just going to do the quick way, but just make note again, there's mashed potatoes, there's chicken. We don't count any of those, but there is ice cream, and ice cream at room temp is a liquid, so you're going to count that one. So I'm going to do the short way. Oops, sorry. 8 ounces plus 6 ounces plus 4 ounces. Okay, so we get 18. Okay, so there's 18 ounces times 30, and we get 540. Okay, so your dinner was 540. That was mLs as well. Forgot to write that. Okay, so now we have that. So we've answered this question here, dinner total. Okay, but now there's another one there. What is the total intake for the day so far? Okay, so we're going to look at breakfast, lunch, and dinner. So hopefully you wrote these down somewhere, you recorded them. If you did, you would have 540 for dinner plus 660 for lunch plus 600 for breakfast. So the total, as of right now, would be 1,800 mLs for the day. Okay. Keep that number as well. Okay. Hold on to that number because we're not done. Okay. Looking at the total input. So if you have a question that's asking you about total input, that means breakfast, lunch, dinner, and IV. Okay, let's write that on here. So breakfast, lunch, dinner, and IV. All of that goes in your total input. Okay, so all those numbers you just obtained. So the patient's IV is running at 100 mLs per hour, and they're receiving that for 12 hours. What's the total IV amount in mLs that they're going to receive? So if they're getting a 100 mLs every hour for 12 hours, you're going to do, let me write it out just in case we need the math, sorry. So 100 mLs times 12, and you're going to get 1,200 or 1,200, okay? So that's the math. So that means what is the total IV? 1,200 mLs, okay? So now, again, we're back to what is the total intake for the day? So remember, for the day means breakfast, lunch, dinner, and IV. So I'm going to write all those numbers out for you. So here's breakfast. That was 600. Lunch was 660. Dinner was 540. IV was 1,200. Okay. So then you're going to add all of those up, and you'll have your total for the day. So 1,200 plus 540 plus 660 plus 600. That gives us 3,000. Okay. So that means your answer here would be 3,000 mLs. Okay. So that's our total. All right. The next thing. Now for the output. And yes, these are all separate questions. Okay, so for the output, the patient also has a urine output of 40 ounces and a wound drainage of 80 ounces. What is the total output? Remember, output is anything like urine, wound drainage, vomit, diarrhea. Okay, so that means these two things here can be counted for their output. So you have 40 ounces plus the 80, ounces. Let's scratch that one. Plus 80 ounces. There we go. So 40 ounces plus 80 ounces gives us 120 ounces. Remember, we're not done because we want it in mLs. So times 30. And we get 3,600. Okay. So that's how much output they had. And that's mLs, so we don't forget that we're trying to convert to mLs. Okay. That was it. Those are the main concepts that you need to go over. I hope this video helps. Also, don't forget your conversion from milligrams to grams to micrograms. Okay, and also don't forget you cannot jump from grams, milligrams, micrograms. You can't jump from grams straight to micrograms, and you cannot go from grams and times it by 2,000. So you need to know the proper steps to convert from grams to milligrams, milligrams to micrograms. Okay.